Hello, I'm Seema and welcome to part 12 of the chapter, The Solid State. The topic of this video is calculations involving unit cell dimensions. As we have studied about the cubic unit cell, imagine that this Rubik's cube is one unit cell and it actually is made up of each one of these small cubes. If you imagine the cubic lattice, each one of these cubes is one unit cell. But for the sake of convenience, because that would be too small to explain, I use this whole unit cell, this whole Rubik's cube as one unit cell to explain things to you. Now that we have studied that we know a few things about the unit cell, we can calculate the volume of a unit cell. And in order to calculate the volume of a unit cell, which is a cube, what is the volume of a cube? The volume of a cube is length into breadth, and height, right? Length, breadth and height. Or from this side, if we take it, length, breadth and height. The three sides, if you multiply the three, and since it's a cube, all length, breadth and height, all of them are the same. They have the same measurement. Therefore, if we say that the length or breadth or the height of the cube is A, it has a value of A, then A cube, whatever that value is in whatever units those are, A cube will give you the volume of the cube. So we can calculate the volume of the unit cell, which is a cubic unit cell. Based on the different kinds of cubic unit cells, we have already calculated that for a simple cubic unit cell, the number of atoms that it should have is 1. Why? Because every corner in a simple cubic unit cell, all the corners of the cube are occupied by an atom. And every unit cell is equally divided by, or rather every ball which is on a corner, every corner is equally divided by 8 unit cells. Imagine how is that? Imagine one of these small unit cells. Imagine this corner is touching 1, 2, 3 other corners, or this corner, this hole here, it is touching 4 different red squares. So these are 4 different cubes under it. If you imagine 4 cubes above this, then the same corner would be touching 4 cubes above it also. So an atom which is present on one corner, imagine it to be the corner of that room, is connected to 4 unit cells on that floor. If you imagine it to be a building, 4 unit cells on that floor and 4 unit cells or 4 rooms on the upper floor. So 4 unit cells here and 4 unit cells above it. So that one atom on one corner is actually shared by 8 different unit cells. So one unit cell gets only 1/8 of that atom, which we imagine to be a ball. So since it is only 1/8, then how many corners does a cube have? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 corners. So there are 8 atoms which are shared equally. Each of those atoms is shared equally by 8 rooms. So in this one unit cell, there are 8 balls, out of each of those balls, only 1/8 of which is present in this unit cell. So 1/8 into 8 will make it, 1/8 into 8 will make it how many actual balls? 1/8 into 8 will make it 1. So there is only 1 actual atom in a simple cubic unit cell. Similarly, if you had the other unit cells, we know, and this is known as the value Z. Z tells you the number of atoms in a unit cell. So if you had a body-centered cubic lattice, instead of a simple cubic lattice, if we had a body-centered cube, then there would be 1 atom present inside, in the middle of the atom. Imagine this to be the unit cell, the room. Then there are 8 balls on 8 corners, that is 4 top corners and 4 bottom corners of the room, and 1 ball in the center of the room. Now the ball that is in the center of the room, imagine that ball to be this cube. This ball belongs only to this room. It does not belong, it is not being shared, it is not on a corner, it is not on a wall, therefore it belongs totally to this room. So for a body-centered cubic unit cell, how many atoms actually belong to that atom, or what is the value of Z? The value of Z would be, it has one atom which is in the center and 1/8 of 8 atoms which are on the corners, which makes it again 1. So 1 of total of the 8 balls on the corners will be 1 atom, and this 1 atom which is in the center of the room would be, or the unit cell would be the second atom. So in that case, in a body-centered cubic unit cell, the number of atoms in a room would be, in the unit cell would be 2, or the value of Z would be 2. We have done this in the previous videos, and I would encourage you to watch those, because there the proper details of this have been explained to you. Similarly, if you have a face-centered cubic or HCP cubic lattice, the value of Z in those cases is 4. Right? So the value of Z could be 4, the value of Z could be 2, the value of Z could be 1 in the case of cubic lattices. Even in the case of a face-centered cubic, where the value of Z is 4, or you imagine an edge-center cubic. Every edge has a ball here in the center. Even edge-centered cubic, if you calculate the value of Z for it, it would come out to be 4. How? Because every corner has 8 balls, and 1/8 of 8 would be 1, but every edge, in the center of every edge you have 1 ball, and an edge is shared by 4 rooms. Imagine this corner of the room, it would be shared by 4 rooms. If you imagine the corner behind you, just look at that corner wherever you're sitting, look at that corner. If you imagine 1 room behind this, 1 room there, and 1 room on that side. So that edge is being divided equally, or being shared equally, by 4 rooms. So every edge is shared by 4 rooms, which means any atom present here would be shared equally by 4 other unit cells. So how many would you have then? If you have 1, how many edges do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So there are 12 edges. There are 12 edges, so there are 12 edge-centered atoms, but each edge-centered atom is divided equally by 4 unit cells. So this will be equal to 3, and 1/8 into 8 is 1. The ones on the corner is 1. So even for a edge-centered cubic unit cell, the value of Z would be equal to 3 plus 1 equal to 4. Right? So now that we understand that we can calculate the value of Z, we can calculate the volume of a cube, we know mathematically, or rather in physics we've studied, that density is mass upon volume. Mass per unit volume is known as density. So clubbing all these together, we get this little equation. And using this, we can carry out calculations which involve unit cell dimensions. So let us now first just read what that relationship is. Suppose by X-ray diffraction, we can calculate the value of A. So suppose we used X-ray diffraction technique and we calculated the value of A for a certain unit cell. The edge length, which is the value of A, is the edge length. All the edges are equal, whether it is length, breadth or height. And we calculate the edge length to be equal to A. Then the volume of the cube or the unit cell, since the unit cell is in the form of a cube, I use these words interchangeably. The cube, room, also I imagine it to be a cube. So all of that is, the cube would be a room, it would be the Rubik's cube, it would be the unit cell. So volume of the unit cell, what would it be? Length into breadth into height. Length is A, breadth is A, height is A. So it will be A into A into A, which is A cube. How can you calculate the mass of a unit cell? How would you know what is the mass of this unit cell? As we know, this cube is only imaginary. The actual atoms, wherever they are, they have mass. The cube is only an imaginary structure that we have joined lines to explain the structure where the atoms are present. So, what would be the mass of this unit cell? The mass would be whatever is the total number of atoms, which we calculate for different types of lattices or different types of unit cells, whatever is the value of Z into the mass of one atom of whatever that element is. Right? So, Z into M. Here we are taking the simplest kind of unit cell where M is just atoms of one kind of one element. If you had a lattice of, let us say, sodium chloride or magnesium chloride, where different kinds of atoms are present, then it would be a little more complex. You will have to go into the details of what is the position of the different ions or different atoms, and what, according to that position, how much of it belongs to the unit cell, and then what would be the value of each one of those atoms in the unit cell, which means that the 4 would then be divided, the 4, the 1 or 2 would then be divided into different atoms or elements, and then you will be calculating the mass of the unit cell. But since we are just starting the study of the solid state, we take the simplest case. We imagine M to be the mass of an atom of an element. So whatever is the number of atoms in a unit cell into the mass of one atom will give you the total mass of the unit cell. Now, how do you calculate the mass of one atom? We know that to calculate the mass of one atom of any element, you should know the molar mass. What is the mass of an atom? The mass of an atom is the molar mass upon Avogadro's number. What is molar mass? Molar mass is nothing but the mass of 1 mole of atoms of that element. What is 1 mole? 1 mole is 6.023 or 22 into 10 to the power 23 atoms of that substance. So, if we want to know, we know molar masses. We do not usually know the absolute or the actual mass of an atom. We know molar masses. So, in order to calculate the mass of one atom, what is the formula? Molar mass. That is the mass of one Avogadro number of atoms divided by Avogadro number of atoms will give you the mass of one atom. So, the mass of one atom is present in a unit cell would be equal to the molar mass divided by Avogadro number. So what is density? Density is mass per unit volume. So if we want to calculate the density of the unit cell, it would mean we would have to divide the mass of the unit cell upon volume of the unit cell, because mass per unit volume is density. So mass of the unit cell divided by volume of the unit cell is density. So density is represented by D is equal to, and what is the mass of a unit cell? Mass of a unit cell is Z into M or Z into M, and the volume is A cube. But M can be written as capital M, that is molar mass upon Avogadro's number. So substituting M with this, we get that density is equal to Zm over A cube Na, where capital M is the molar mass, Na is the Avogadro number, A cube is the volume of the cube, assuming that A is the edge length and Z is the number of atoms in that unit cell. Or D is, we just remove the dots, is Zm upon A cube Na. This is the relationship that we get, based on which we carry out the calculations that involve the unit. These are the unit cell dimensions based on which we carry out the calculations about the solid. So now I'll be solving this one problem in this video, and we'll be carrying on this topic in the next video also. So let me just find my pen so that I can read out this question and then solve it for you too. This pen isn't dark enough, so give me a moment. Alright, so this is the question that I'm going to solve. The question is a solved example of your textbook, which is example 1.3. The question reads, an element has BCC structure. BCC structure means body-centered cubic. It is a cubic structure. It has got balls on all the corners of the room, and there is one in the center of the room, the body center, which I showed with this cube. That imagine there is one ball in the center of the room and balls on corners. What is the value of Z for a body-centered cubic unit cell? The value of Z for a body-centered unit cell is 2, because one atom in the center belongs to the room, that is to the unit cell, and 1/8 of 8 balls would be 1. So total 1 plus 1 is 2. So an element has body-centered cubic structure with a cell edge of 288 picometers. So cell edge means that's A. A is equal to 288 picometers. Picometers, if you have to convert, 1 picometer is 10 to the power minus 12 meter. So in other words, it is 10 to the power minus 10 centimeters. So let us convert it into centimeter. Why? Because when you come down here, you'll see the density is in centimeter cube. So let me convert this into centimeter cube. This would be equal to, which will be equal to 288 into 10 to the power minus 10 centimeter. Okay. The density of the element D is given as 7.2 grams per centimeter cube. How many atoms are present in mass is given. This is not mass of the atom actually. It is the mass of atom is represented by the small m. So I write mass of the substance. Mass is 208 grams of the element. This is a mass that has been given to us. So we have to find out how many atoms are present in 208 grams of the element. In order to find out, first we must know the mass of one atom. And only then we would know if this is the mass of one atom, what is the mass, how many atoms would be there in 208 grams of the substance. So there are two ways of going about this question. One is the one that's given in the textbook, and one is how I would do it. I'm not very good mathematically, so I really go, some of you might find my method easier, some of you might find the book easier, but I'll solve it in both ways. So according to what I understand is that the relationship that I have is that density is equal to Zm upon A cube, right? Zm upon A cube, where here I'm not concerned about the molar mass because I do not know the element. And therefore, I just need to find out the mass of one atom, which I can from whatever has been given to me. So Zm upon A cube, where Z I already know is 2, M is to be calculated, A is given to me, which is 288 into 10 to the power minus 10 centimeter, right? Yes. So if I calculate the value of A cube, that is if I multiply 2 point, which is equal to 2, now density is given to us, so let me just change this. Since density is given to us, I have to calculate M. M would be equal to D into A cube upon Z. Does that make sense to you? So all I did was just single out the mass of an atom that I am supposed to find out first. So density that is given to us is 7.2 grams per centimeter cube, or instead of writing per centimeter cube, let me write centimeter inverse, centimeter cube inverse. So into A cube, 288 into 10 to the power minus 10 centimeter. If I find the cube of this comes out to be 2.39 into 10 to the power 2.39 into 10 to the power minus 23 centimeter cube. Okay, so do you see the centimeter minus cube and the centimeter cube will get cancelled here. In the end, I'm calculating mass, so I will get the my answer should be in grams, and Z is only a number which is equal to 2 in the case of a body-centered cubic cell, so Z is 2. If I solve this now, what is the value that I get? What is the mass of one atom that I get? According to this, when I solved this, I used a calculator for it, but unfortunately in India, children are not allowed to use calculators. I feel so sorry for that. So you would have to calculate this on your own. Although here in the US, they do allow calculators, which makes it so much easier. And I really hate calculations. So I used a calculator. I'm not stuck to give an exam, but you please try and solve it yourself. But using the calculator, I found out that this happened to be 8.6 into 10 to the power minus 23 grams. Right? So what did I calculate? I calculated the mass of one atom. And what was the question? How many atoms are present in 208 grams of the element? So if the total mass is 208 grams, in 208 grams is the total mass. If I divide it by the mass of one atom, I will get the total number of atoms. So number of atoms would be equal to 208 grams upon the mass of one atom, which is 8.6 into 10 to the power minus 23 grams. The grams would get cancelled out and you'll get the number of atoms now. And when you solve this, the number of atoms that I get would be 24.19 or 18, I guess. 24.19 into 10 to the power 23. That is the number of atoms that I would get. That is the number of atoms of this element that would be present in 208 grams of the element. So this is my way how I tried to solve this problem. Let us now follow the method that the book that has been followed in your textbook. So I'll just leave this part as it is, and I'll rub this off, and let us try to solve this as given in the book. The approach taken by the book. So in the book, the first thing they do is find out the value of A cube. Okay, that is the volume. A cube was found out to be equal to 2.39 into 10 to the power minus 23, I guess. And volume, so centimeter cube. That was the volume found out. Now, this is the volume of one unit cell. So if you had the volume of 208 grams of the element, how could you, we know that density is equal to mass upon volume. So what would the volume of the unit cell be? Density of the unit cell is mass of the unit cell upon volume of the unit cell. Therefore, volume can be equal to mass upon density. You're just interchanging, it's just a mathematical operation that I did. Like I cross multiplied, or I don't know what is it called, that I interchanged it. So the volume would be equal to mass upon density. So how would you calculate the mass that is given? This is this mass, not the mass of one atom. The mass. The mass is equal to 208 grams upon density is given to us is 7.2 grams per centimeter cube. So if I put the centimeter cube per centimeter cube in the numerator here, so centimeter cube, gram and gram will get cancelled. 208 upon 7.2 will give you the volume of the substance. The volume would be 28.88 centimeter cube. Right? This is the volume, the total volume of 208 grams of the substance. So 208 grams is the total volume, and what is the volume of one unit cell? The volume of one unit cell is A cube. So if we want to find out what is the number of unit cells, from this we can calculate. This is the total volume. Total volume upon volume of unit cell will give you number of unit cells. So let us find out what is the number of unit cells. The total volume is 28.88 centimeter cube, and if you divide it by the volume of one unit cell, which is 2.39 into 10 to the power minus 23 centimeter cube, the centimeter cube will get cancelled. You will get the number of unit cells. From this, the number of unit cells that you get would be equal to, according to the book, would be equal to 12.08 into 10 to the power 23 unit cells. Right? If this is the number of unit cells, we know that in a body-centered cubic cell, in every unit cell there are two atoms. So if this is the number of unit cells, every cell has two atoms, then all you have to do is multiply this 12.08 into 10 to the power 23 into 2 will give you the number of atoms, which will come out to be the same. That is 24.16 into 10 to the power 23 atoms of the substance. So it's basically the same thing, only here they went stepwise and I straight away grabbed the final equation and I tried to solve it like that. Just two different approaches. Do whatever feels easier to you. Follow your mental maths. My mental maths, you might find it easier, you might find it difficult, whatever, but this is what the book tells you, so try to solve it whichever way you find is easier. So with this, I'll wind up today's video. In the next video, I'm going to solve the other two problems also, and if possible, I'll try to solve one of the unsolved, the in-text questions also. So I'll wind up this video now. If you found it helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. And if you wish to watch other videos of this chapter, please click the link that will appear on top, and you could see all the other parts of this chapter too. So thank you for now, and bye-bye.